Lab 2, Projectile Motion. So here's the table of contents. The purpose of this lab is to study the effects of drag force on a ball of paper after it is thrown through the air. The experimental measurements were calculated using tracker, and the projected measurements were determined with code. The main formulas used in this lab were velocity update, position update, and drag force formulas. Overall, the results show that the drag force had a very small impact on the paper ball since it has such a small mass. So the position update formula is derived from kinematics, and it is used to find the paper ball's position after a certain time interval, and then the velocity update formula is used to find the velocity after applied forces are taken into account. The drag force formula is shown below, and it represents the amount of air resistance on an object, and drag force opposes the direction of motion. Here are the system surroundings and initial conditions. So for tracker, I used it to track the time and position of the ball of paper through the air, and I turned the data into this table. For the code, I took the position and velocity from tracker. As you can see, the proportionality constant for the drag force is set to 0. On the object, I set force net equal to force gravity plus force of drag, and force of drag equals 0, obviously, for this part, so it's just the force of gravity acting on the object. And then I updated the ball's velocity and position. And the code that goes along with it. And then here is the output of the code without drag. So for the initial conditions on the code with drag, the only thing that I changed was the proportionality constant for the drag force. And then coding the calculation loop, to calculate the net force, I set F net equal to F grav plus F drag, and in this case, the drag force was the formula that I previously mentioned. And then here's the vector representation. As you can see, the orange arrow is the drag force opposing gravity in this case. And then here's the output of the code with drag. And then the chart that I put together. So some possible errors were obviously using tracker. It is difficult to plot a point correctly, and then also it was difficult to find like the specific value for the drag constant, so there was a bit of trial and error in finding that. Some similarities between the model was that each showed a slope initially increasing as the object was thrown up, and then decreasing as the object fell. Some differences, obviously due to errors, there were some discrepancies in the experimental data versus the computational data. The drag was evident according to the chart because it showed how the path of the paper ball was slowed due to an opposing force. In the model with drag, velocity in the y direction begins to approach a terminal velocity towards the end of the time frame as shown in the picture to the right. This is because drag and gravity slowly cancel each other out, and the sum of forces in the y direction equals 0. The model without drag shows no terminal velocity because there is no opposing force to counter the gravitational force. To where the object had been thrown straight up. This would not have affected the amount of time that it took for the object to reach the ground. If they both had the same initial velocity, they would hit the ground at the same time because the y-axis is independent of the x-axis. Despite some discrepancies, the three models show the drag force counteracts gravity. And that's it. Thank you.